Hello and welcome everyone to today's coding challenge. This is 18 June 2K25 and today we are discussing a problem of the day on Geeks for Geeks. The problem is find all possible palindromic substrings or partitions of a string. And in this problem we have given a string S and we have to find all possible ways to partition this string such that every substring in the partition is a palindrome in itself. And if we look at the example number 1, we have given S equals to geeks and the possible partitions is GEEKS, that means the single letter partitions in itself is a palindrome. So this first subset contains all the partitions which are of single length, and as we all know that single length partitions is palindrome in itself. And in this second subset we partition like this G, this E and E, this K and this S. So these are the possible partitions for this example number 1. So what will be the basic intuition behind this problem? The basic intuition behind this problem is finding all subsets of this string, and amongst those subsets we can choose those subsets who are palindrome in itself. So how to find the all possible subsets for every string? So we have to basically use the principle of inclusion and exclusion to find the subsets of a string or an array. So let us first visualize our code for this problem. This is the code for this problem, and we have to first try run this code for this example number 1. And as we know that this is S equals to GEEKS, the example number 1, we have to first initialize our result, that means a empty list, and n is the length of this input, and this time it is 5. And then we can call our function backtrack with 0 index and a empty list in it, and finally we have to return our result. So what could happen if we call our function backtrack? So this backtrack calls itself and our start is 0. Here we can see that, and this is our empty list first. So let us erase this G first. This is our empty list. Now let us delete this. First this if condition gets checked, that means is that this 0 is equals to this n? No, it is not. So our for loop will start for I in the range start till n, that means this is 0 this time, so this is 0 till 5, and our substring contains the substring for this start till I plus 1th index, that means 0 till 1 index, and 0 till 1 index SB receives only G. This is basically means starts from 0, goes to 1 and exclude that, that means this G only. So this is G only, and check that if it is a palindrome or not. And as we know that the single element in itself is a palindrome. So this is true. Current partition dot append that substring. So this is our current partition and we have to append our g in this, and again we have to call our backtrack for I plus 1 and current partition. So this this function calls itself like this, but this time our start is actually I plus 1, that is previous. This is 0, so this time it is 1. Update our start, this is 1. Now again we can check that whether this start is equals to n. No, it is not. So our for loop will start from 1 till this 5. So this substring contains this time that s of 1 till 2, that means this. And what does it receives now? We can see that from 1, that means from this index till second index means this, and we have to exclude that as, so only this e, so this will receive e only. Now check if it is a palindrome or not, and the single element in itself is always a palindrome, so put that inside the current partition, that means this. Again call the backtrack for I plus 1 this time. So again we have to call this I plus 1. I is previously 1, so this time I is 2. This time I is 2. For loop will start from 2 and this will start from 2 till 3, and this contains e as well. Now our SB will receive substring of this s from index 2 till index 3, that means from this index 2 till this index 3, but 3 is excluded, so it will only receive e. So this time it receives e, and again it checks if it is a palindrome or not. Yes, it is a palindrome, so put that inside our current partition, and all these previous functions are on hold till now. And again our backtrack function calls itself for I plus 1. So again our function gets called itself. Start is 2 previously, so this time it will be 3. Erase this. Start is 3 now, so our for loop will starts from 3 and goes till 5. This is 3 2 4, and this contains e and e. So now what will this SB receives? This will receive from index 3, that means from this k till index 4, and 4 is excluded, so only k. So append k this time. And again call for I plus 1. So let us copy this, and for now this function gets on hold and it will call for I plus 1. I is previously 3, so this time it is 4. So this is 4 now. Start is 4. For loop will starts from this 4 till index 5, and this will find the substring from index 4 till index 5. That means from this index till index 5, and that index is excluded, so only this S. This receives S, so we have to update our current partition because it is a single element, and single element in itself is always a palindrome. Now again this backtrack is call itself, and this time our start is 5. So let us copy this and paste it here. This time our start is 5, so update our start from 4 to 5. But now when our start is 5, this if condition gets true, that means start is equals to 5, so we have to append the current partition into our result. But let us look at this list first. We have to first convert our current partition into a list, and this is basically made a new list object and then append into this result. So let us suppose this is our result, a empty result, and in that this will receive G, E, E, K and S. This is our final result list. Now checking this, we have to return from this. So we do not start our for loop and finally return from this state to the previous call. So let us erase this function. Erase this and then delete this. So our control gets back to this function, and we have completed till this line. After completing our backtrack, we have to pop out from our current partition list. So pop out this S, and then this for loop gets completed, and there are no lines for this functions to get completed. This if gets completed, then this for loop is still not completed. This for loop is still have one iteration left. So this for loop now starts from this 5 to 5, and to this 5 to 5 our SB is 5 to 5, and this time this 5 is an invalid index for this, so this will do not find any substring, and this F is also not executed, so our for loop gets completed. And after completing our for loop, there are no further operations left for this function, so this will return to its previous calls. So this function gets over and return to its previous calls. So let us delete this. Here we can check that after completing this line, that means this SB, and calling our backtrack for this, we have to pop out from this. That means first pop out from this current partition list. So let us pop out this from this current partition, and after popping out this current partition, this if gets over, so our for is still not completed yet, and our I is incremented. So our I is incremented from this 3 to 4. So this is 4 to 4, and as we can see that this is 0, 1, 2, 3 and 4. 4 to 4 is only this a empty string. That means let us look at this CMD. If we try to find 4 to 4, this will receives nothing. So this SB receives an empty substring, and this empty substring is basically is not a palindrome in itself. So our I is again incremented from 4 to 5, and for 5 our for loop does not execute, so this function gets over, and after completing our for loop there are no statements for this function, so this will return back to its previous call. So this will return to its previous call. Again let us delete this first. Here as we can see that after completing this, we have to first pop out from our current partition list. So let us first pop out this E from our current partition list, and popping out from this current partition list, our I gets incremented from its previous value to the next, and this is 3 to 5, and our substring will receive this time the start is still 2, and this I is now 3, so this is 2 to 4 this time. And as we can see that if we have print our this substring from 2 to 4, this will receive this E and K, so this will receive E K this time, not this receives E and E K this time, and this if gets checked for whether it is a palindrome or not, and this palindrome function, when check this, we can clearly see that this is not a palindrome, so this if will not execute and our I gets incremented. Our I is 4 now, and start is still 2 for this function, so this will update it from start to I plus 1, that is from 2 to this 4 plus 1, that means this 5, and we can check that from 2 to 5 this will receive EKS, so this will receive EKS, and again it will check that whether it is a palindrome or not, and as we can see this is not a palindrome, so this if will not execute, and our I when increments from 4 to 5, this for loop is over, and after completing this for loop there are no statements after this for to check, so this function will return, and when it gets returned, it gets to its previous call. So let us first erase this function. Let us erase this, and here after completing this SB, that means this backtrack, we have to first pop out from our current partition, that means pop out from here, after popping out this if gets over, so our I is incremented from its previous value to the next, that means from this 1 to 2, and our start is still 1, so this is from 1 till 2 plus 1, that means 3, so our SB is now S of 1 till 3, that means this EE, this will receive EE, and when it check that whether it is a palindrome or not, we can clearly see that this is a palindrome, so this if is true this time, so we have to append this in our substring, so this is EE, and After that we have to again call our function for I plus 1. This time our I is 2. Our current I is 2. So let us call our function that means this, and our start is now this 2 plus 1. That means our start is now updated to 3. So update our start from 2 to 3. That means this is 3. Our for loop will now starts from 3. So update this 2 to 3 and erase the previous value. Erase these as well. Now when our for loop starts from 3 till this 5, this substring will now receive this s of 3 till I plus 1, that is 3 till 4. So this will receive 3 till 4, and as we can see that this s is 3 till 4 is only this k, so this will receive k, and this k is a palindrome in itself. So this, if it's true, so we have to put that inside our current partition. So let us put this inside our current partition here, and now call the same function for I plus 1. So this same function now gets called for I plus 1. I is 3 here, so this start is updated to 4. That means this I plus 1. So this is 4, and as we can see that our for loop will starts from 4 till n, that means 4 till 5. Now this SB will receive the values from start, that means from 4 till I plus 1, from 4 and I is 4 till 5. So what is the substring from 4 till 5? That means this S only. So this will receive S, and now we can check that whether this S is a substring in itself or not, and we know the single elements in itself are always the palindrome in itself. So this if gets true, so we have to put that inside our current partition. So put this S inside our current partition. After doing this, call the backtrack again for I plus 1. I is currently 4 now, so call this function for 5. Let us move this inside. Now let us copy this and call this time. This st is 5, so update this from 4 to 5, and when this start is 5, it will check this condition that this start is equals to n and n is 5, so this gets true. We have to append our current partition list inside our final result. So our current partition list is this G, double E, K and S. So this will create a copy of this G, double E, this K and this S. After doing this function gets returned. So after doing this all, these for loop will not execute it and this function gets returned to its previous call. So let us erase this. And comes here, and after doing this backtrack for the current function, we have to pop out from our current partition. So pop out this S, let us pop out this S. Popping out this S and increment our I, and when we increment our I, this will basically do not increment because our current I is 4 and this has to be less than this 5, so for loop will completed, and after for loop there are no lines to execute, so this function will return to its previous parent call. So let us erase this and now move to its parent, that means here, and here we can check that after completing our backtrack what we have to do. We have to pop out from our current partition list, that means pop out this. So after popping out this K, we have to increment our I. So I is 3 now, so update our I from 3 to 4 and erase our this I. Now this SB will receive the substring value from start, that means start is still 3 and this I is 4, so this is I plus 1, that means 4 plus 1, that is 5. So this will receive the substring from 3 to 5. So what is the substring from 3 to 5? That is KS. So this will receive KS. And now the if condition gets checked whether that KS is a palindrome or not, and we know that KS is not a palindrome in itself, so this if will never execute and our I also did not increment because when we increment our I from 4 to 5, this the condition for loop will get false, so our for loop will now completed here, and after that for loop there are no further lines to execute, so this function gets returned to its previous parent, that means from here to here. So let us erase this, delete this, and delete them also. Now here, after doing this backtracking function, we have to first pop out from our current stack. So pop out this EE from our current stack, and this if is now over, so our I is incremented now. This is 3 now, so update this 3 to 3, and we have to now find the substring from start, that means from 1 to 4. So up this is 4, and the substring from 1 to 4 is EEK, so this will receive value EEK, and again the condition gets checked for whether the EEK is a palindrome or not. It is not a palindrome, so update our I from 3 to 4, so this is 4 now. Now our SB will receive the values from start, that means from 1 to I plus 1, that means 4 plus 1, that is 5. So update this to this. And what is the substring from 1 to 5? That means from this 1 index till this, that means this EEKS. So this will receive EEKS, and as we know that this is not a palindrome in itself, this is palindrome will return false for this, so this if loop does not execute, and our I is also not incremented again because our for loop is completed, so we have to return back from this function to its parent calling function. So we have to delete this, and now comes here. After completing this backtracking, we have to now pop out from our current partition first. So let us pop out this G, and after popping out this G from this current partition, what we have to do, our I is incremented, and when our I is incremented, the value is now from 1 to 5. So now our SB will receive values from 1 to I plus 1, that means 2, that is this 2. Let us first erase the previous values first, and now again this is 2, and now this SB will receive from 0 till 2, that means 0 and 1, that is this GE. And when we check our palindrome function for this GE, this is basically not a palindrome, so our I gets incremented. This is 2 now. Let us erase this, and our SB will receive values from this 0 till this 2 plus 1, that is 3. So this is 3 this time, and SB will receive values from 0 till 3. So what is the 0 till 3? That is GEE. So this will receive GEE, and this if function, if condition check that whether this string is a palindrome or not, and we can see that this is not a palindrome, so this if will never execute, and our I again gets incremented from 2 to 3, and SB will now receive values from 0 to I plus 1, that means 4. So this is 4. And what is 0 till 4? That means this GEK, and again this if will check that whether this GEK is a palindrome or not. This is not a palindrome, so again our I gets incremented, so this is 4 now, and this receives 0 till 5, and 0 till 5 is basically this GEKS, and again our if checked that whether this string is a palindrome or not. So this is not a palindrome, so this if will never execute, and our for loop is also over this time, because our for loop will not go to this 5. So this will now over, and this will now calls backtrack to its parent function. So delete this. After deleting this the interpreter comes here, and there are no further more lines here after this backtrack. So this final line will execute now, and this will return our this result to the caller function. So this is our final result, and this final results is now received for this first input. So this will conclude our basically our visualization for this question. So let us now code this and check if it is correct or not. So let us code this in Python. The code is pre-written by me, and it is the same code that I just explained. So let us run this and check if it is running fine or not. It is running fine, so let us submit this first. So this is correct, and it does passes all the test cases. So thank you so much guys to clearly listen this problem, and if you understand this concept, please do like and subscribe to this YouTube channel, and do keep coding daily, and like and subscribe to this YouTube channel. Thank you so much guys.